Hi everybody, this is going to be our first Unit 3 video and we're going to talk about piecewise functions. Now when you look at this graph over here, you're probably noticing we've got three different pieces. So each of these three pieces come together to make a piecewise function. Okay, we have multiple functions resulting in multiple graphs that are all part of one piecewise function, and each one of these pieces has its own domain, its own set of x values that it lives in. So let's look at what it looks like notation-wise. Okay, here we have a piecewise function g of x, and we have three different functions there in the bracket. Now, we determine which function we want to use depending on what x values we're actually working with. So if we have x values that fall in this domain, then we would use the first function. If we have x values in this domain, we would use the middle function. And if they fall in this domain, then we use the third function. So it really just depends what x values you're working with. So let's look at example A here. If I want to evaluate this function g of x at an x value of 2, I need to decide where that x value of 2 lives as far as this function goes. Well, 2 is greater than 1, so it's going to be the bottom function here. Okay, so if I want to know what the function is at an x value of 2, I need to plug 2 into that bottom function. And then we're just simplifying. So we would get 2 times 8 plus 9. So we get 16 plus 9, which gives us 25. Okay, same thing for B. I want to evaluate this at -1. Well, -1 is in between -4 and +1, so I'm going to use that middle function this time. And when we simplify, we get 0. Okay, for our last one here, -6 is less than -4, so we're using that top function. And again, just like the other ones, I'm just plugging in my x value and simplifying. And once again, we get 0. So this is what the notation looks like for a piecewise function. It won't always be three different functions there. Sometimes it's just 2, but a lot of times it's 3. And each function in this piecewise function is going to have its own domain. Okay, notice that there is no overlap with the x values. And when I say that, you have to really pay attention to the signs here. Let me pick a different color. Okay, notice that for the first one, I can have x values less than or equal to -4. But then when I get here, I can only have x values greater than -4. So even though the domains are stopping at like the same number, only one of those domains actually includes that value of -4. Okay, so you're going to have to really be careful with the domains here, really pay attention to what x values are being included and excluded. So let's actually graph one. All right, so here we have a piecewise function. We have 3 parts to it. So what I like to do is I like to graph the whole thing, like each line at a time, and then erase what I don't need. So g of x equals -1. That's my first function. Now, since there's no variable, this is just a horizontal line that goes through -1 on the y-axis. So I'm going to go ahead and draw in my horizontal line, and then we'll decide where to cut it off. All right, so there's the whole thing there. Now, I only need the graph for x values less than or equal to -5. Well, an x value of -5 is here, and the x values less than that are to the left. So I'm going to erase everything to the right of that point. Now, notice that my point is solid because x is less than or equal to -5. We only fill in the circle if it can equal that value. So let's move on here. Let me pick a different color. Let's do green. So now let's do the middle one. Negative x minus 3, okay, that's a line. So we can do our slope and our y-intercept to graph that. So we'll start with our y-intercept of negative 3. The slope is negative 1. Okay, and we can fill in a bunch of points. Now, remember, though, before I connect this, I'm going to be a little strategic here. Before I connect the points, I'm going to see what points I actually need to keep, because I only want x values between negative 5, which is here, and positive 1, which is here. I don't need anything to the left of negative 5, and I don't need anything to the right of positive 1. I'm also not able to actually make them equal to negative 5 or positive 1. So I'm going to have open circles on both ends. So I'm going to erase this, put a nice open circle. Same thing here. And then I'm going to connect. All right, so there's our middle section. Let's pick one more color. Go blue. All right, and our last function here is just 6, so that is a horizontal line again. I'm going to draw the whole thing in. There we go. And I only want to keep the part of the graph that has x values greater than or equal to 1. So that's where it's equal to 1. I'm going to get rid of everything to the left because those values are less than 1. And there you have it. There is my piecewise function graph. Okay, 3 distinct parts. Now, the tricky part here is we still need to do the domain and the range. Okay, well, domain is the x values that it covers, so I'm going to look from left to right, and I'm going to really focus on those break points. Okay, when we get to that x value of negative 5, when we get to this x value right here, we have to be really careful, and we need to make sure that the x value of negative 5 is actually included as a point on one of those lines. It's possible that both of those circles could be open, and I would have to exclude that x value from my domain. In this case, the red line is actually including a value of negative 5, so we're good. But we have another breaking point here where it's disconnected as well. So we need to check this spot. Okay, but again, the blue line actually includes an x value of positive 1. So we can say that the domain is all real numbers. Everything from negative to positive infinity is included in the domain. Now the range is going to be a little trickier. So here's what I'm going to do. We know that for the blue line, all of the y values along that horizontal line are equal to 6. For the red line down here, we know that all of the y values along that horizontal line are equal to negative 1. For the green line, we know that the range, the y values, goes from a minimum of negative 4 to a maximum of positive 2. So I'm just kind of writing in each individual range here. What I want you to notice is that the range y equals negative 1, that y value is already included in this inequality here. Because of that, I don't need to be redundant. I don't have to include this range when I actually write my formal range. Okay. However, y equals 6 falls outside of the range. So I'm going to have this piece and this piece, not this one, included in my formal range when I write it here. So we're going to say the range is all of the y values such that y is between negative 4 and 2, or y is equal to 6. Okay, that includes all possible y values. Our y values are going to either be between negative 2 and 4, or I'm sorry, I said that backwards. They're going to be between negative 4 and 2, or they're going to be equal to 6. There is no other option. Every single point on this graph that you can find will have a y value that fits into one of those two places. All right, guys, that is it for this video. I know it's a longer one, and I know it's very confusing, but we'll have a lot more practice with this. So let me know if you have any other questions, and have a wonderful day.